All right, folks, this is the review for test. So the idea here is we're going to take these 5 graphs and we're going to show different kinds of associations. This first one will be positive, strong, and linear. Positivo, fuerte y lineal. Okay. The idea here is that your points on your scatter plot are going to be like clustered pretty closely to a line if you were to draw through it. Okay. Next, we'll do negative, strong, and also linear, right? They're linear because you can draw a line through them. This is positive because it goes up. Negative is actually going to go down, right? So it'll form a general downward trend that you could draw a line through the middle of it, okay? Next, we'll do positive, weak, and linear. Okay? And the idea here is that it's going to follow that same trend, right? But rather than the points being closely packed, they're kind of scattered like that. You can still see that it's got a general positive trend going through here, but the points are not like really tightly close to a line, right? Next one, we'll do negative, weak, and linear. Okay. It's going to be similar to this, but it's going to be like kind of the opposite direction, right? So they're again scattered pretty, but again, it's kind of like that downward trend. You could draw a line through the middle of that if you wanted to. Okay, last one, no association. This is when there's really no pattern. You can't really draw a line through it. The points will kind of just be scattered all around like that, okay? There's not really any rhyme or reason you can make of that. So, so yeah. Cool. All right, use this two-way frequency table to answer the questions. We have this broken up to 2 types of data, whether someone likes Pepsi or Coke, and whether they play Call of Duty or Minecraft. So how many students play Call of Duty? The idea here is that you're going to look at the Call of Duty whole row right here. I'm not asking whether they like Coke or Pepsi in the first one. I'm just asking if they play Call of Duty. So that's going to be 65 plus 40 gets us to 105, right? So 105 students play Call of Duty. Okay, now, how many students play Minecraft and like Coke? We look at Minecraft, we like Coke, and we see where they combine is at 70, right? So pretty easy. We'd say 70 students play Minecraft and like Coke. So that's the idea with that frequency table right there. So we're going to solve this. First thing we're going to do is distribute. We're going to solve for x. So we multiply here to get rid of the parentheses. That gets us to negative 15, negative 5 times 3, and then negative 5 times a negative 2x is a positive 10x. 3 times x is 3x. 3 times 7 is 21. Bring down that 4x. Now we're going to combine like terms, these two, okay? So we're at negative 15 plus 10x. I haven't done anything with that yet in this step. That gets us to, 7x plus 21. Now I want to take this 7x and combine it with that 10x. It is positive, so I have to do the inverse, so I subtract it. Dang, just mistakes all over. 10 minus 7 is 3. X equals 21. Now I have this negative 15. I want to bring it to the other side. The inverse of being negative is positive, so I add it. We get to 3x equals 36. Now I've got 3 times x. The inverse or opposite of multiplication is division, so I get x equals 12. Kaboom. Okay. Okay. Answer the following questions about this scatter plot. Is this proportional? Well, the idea here is that if I draw a trend line, I can kind of see where it hits the y-axis, and it's going to be right about there, right? Maybe I could have made it go up a little bit, but it definitely seems like it's going through the origin or at 0, 0, right? So that's kind of one of the definitions of a proportional relationship. So I'd say, yes, it's proportional because it goes through 0, 0. The other part of the definition of being proportional is that it is a line, right, or has a constant rate of change, which This trend line, you draw a general line through it, that's going to be linear, okay? So what is the y-intercept? The y-intercept is where it crosses the y-axis, so this point right here is 0, 0. So b equals 0. And so what is an equation that can model this data? Now, a proportional relationship is going to be in the form of y equals mx, right? Which is, based off that y equals mx plus b. But since it's proportional, part of the definition is that it goes through 0, 0, that b is going to be 0, right? So it's kind of just a variation of that basic form right there. So what is an equation that models this data? We need to find the slope for this, right? And so the idea here is I have a point at 0, 0. I'm also going to get a point here at like 1040. Okay, don't worry, on the test the graph is better and it'll be much easier to find a point. Okay, so the idea here is that we're going to use that slope formula, y2 minus y1 over x2 minus x1. And I've got those 2 points, 0, 0 and 1040. And I'm going to take these four numbers and kind of like break them apart and plug them into this formula right here. This is my first point, so it's x1 and y1. This is my second point, so it's x2 and y2. Now I'm going to put it together. It's going to be 40 minus 0, the y2 minus y1. And then on the bottom, it's going to be 10 minus 0, so 10 minus 0, because it's x2 minus x1. So that gets us to 40 over 10, which we divide to get m equals 4. Okay, so now our equation is going to be in the form of that y equals mx, because we know it's proportional, right? So it's going to be y equals 4x. Technically, you could add that plus 0 if you wanted to make it in that form, but to be super correct, we just want it in that y equals 4x right there. Yeah. So how many car parts would be produced after 60 minutes? So 60 minutes, that's time in minutes on our x-axis. So we're going to take that x equals 60, we're going to take that y equals 4x, that equation that we just made, and we're going to take that 60 and plug it in right there. So that becomes y equals 4 times 60, okay? 4 times 6 is 24. If you add that 0 on there, you get to 240. So a summary would be 240 car parts would be produced in 60 minutes. Okay. Again, another way to think about this being proportional, when you first turn that machine on to make car parts, at time 0, when you first turn it on, it's not making any parts. So at time 0, there are 0 parts. And so that's kind of the idea of how we talk about that as being proportional. Okay. Okay, so x squared equals 25. You want to square root both sides to get rid of the exponent in there. So that becomes x equals, and then I know that 5 times 5 is 25, right? So x equals, dang it, come on, Wishart. X equals 5, right? Now, that's not it. We're halfway done, okay? The other answer is x equals -5, because -5 times -5 is also equal to a positive 25, because the negatives cancel out when you multiply. So this technically has two answers, positive 5 and -5. Now, we do something similar here. We cube root, though, here to get rid of the exponent. So that becomes x equals 5, right? And I double check it. 5 times 5 times 5 gets us to 125, which it should be negative, right? So, boom, that is not correct. If I do a -5, however, I see -5 times -5 is a positive 25, and then I multiply by another -5, and I end up with a -125, which, that's what that is. So, there's only one answer to this one. It is a -5, and the reason is because it's cubed. So you're multiplying 3 times instead of 2 times. Okay? All right, two functions. Answer the questions. Write an equation that models function A. So the idea here is we got to find the slope. Okay, this is rise over run. It goes up 6 and over 2. Slope is rise over run, which is 6 over 2, which is 3. The y-intercept is 0, right? So again, it's going to be in that form of y equals mx plus b, but that b is gone, right? So it's just going to be y equals mx, so that becomes y equals 3x. That's the equation for function A. What are the steps you used? Well, you're going to have to do that on your own, okay? basically write the steps out for finding the y-intercept of 3 and the y-intercept of 0 and the slope of 3. Okay, which equation has a larger rate of change? I should say which function, my bad. Okay, so I know that A has a slope of 3, that m equals 3. Now B, we look at this and we say rise over run, right? So the y values are rise, the x values are run. Change these actually. 8, 16, 24, 32. So these are going up by 8 and by 2. So m equals rise over run equals 8 over 2 equals 4. So m equals 4. So which of those has a larger rate of change? Function B. Oh, again, when it says rate of change, that's slope. Okay. Okay, just a reminder there. Okay. Yeah, there you go. Okay. So we got this scatter plot right here. What kind of association does this have? Well, it's linear because it has a line through it. It is positive and it is strong. So I would say positive, strong, linear. Okay. And again, we're going to do the slope here. I've got 2 points at 0, 8 and 1640. Okay, so that's x1, y1, x2, y2. So this is 40 minus 8. Those are the y's on top. And then the x is a 16. Dang it. Yeah, 16 minus 0 on the bottom. Shoot. That gets us 32 over 16, which is 2. So the slope of the scatter plot is 2. What is the y-intercept of the scatter plot? That's our b value. That's actually going to be where it crosses the y-axis at 8. Okay? And then what equation could be used to model this data? We just got our m, we've got our b. That m goes right there. That b goes right there. So it becomes y equals 2x plus 8. Ta-da! Okay. All right. Survey was given to 2,000 randomly selected middle school students. The results of the survey are shown below. Answer the following questions. So the two-way frequency table talks about having a pet or not, and then whether you play a sport or not, at least one sport. Is it true that there are more students that don't have a pet than do have a pet? So if we say, we kind of just break it down to pet and no pet. There's not a lot of room on this one, my bad. You've got a little room here if you need to kind of like draw an arrow. So having a pet is 400 plus 300. Is 700, and then no pet is 700 plus 600. Okay, so this is asking, is it true that there are more students that don't have a pet than do? Yes. Okay, so that's true, and the reason is because 1300 is bigger than or greater than 700. Okay, is it true that less than 50% of students do not play any sports? So we'll say sports versus no sport. Okay, kind of the same thing, right? Play at least one sport is 400 plus 700, which is 1100. And then 300 plus 600 for no sport is 900. Okay, I'm running out of room here, so I'm just going to bring this down here. And I'm going to say, oops, this should be equal to 900. I would say this is true because 900 is less than 2,000, or is less than 50% of 2,000. True, 900 is less than 50% of the total of 2,000. Okay. Is it true that a total of 400 students have a pet? So we look at the have a pet column. It's 400 plus 300, which is 700. So we'd say false. 700 students have a pet for C. Okay. Again, that's how we interpret these two-way frequency tables. All right. So Miss Nichols' science class was studying the effects of sunlight on plant growth. The equation y equals 2x plus 8 models their data, where y is the height of the plant after x hours of sunlight. So what does the number 8 represent? So 8, represents the height of the plant at the beginning of the experiment. That's the initial value, that's the y-intercept, okay? It represents the height of the plant at the beginning of the experiment. Okay, what does the 2 represent? That's, how did I phrase this in class? 2 represents the rate of change, right? The rate the plant grows per x, and again, per x is the hour of sunlight, so per hour of sunlight. Whew. Okay, 2 more. We're on an 18-minute video, 20-minute video. Okay, rate of change, again, slope. Okay, rise, over, run, slope, or the m value is rise, over, run. So you figure out the pattern for your y values. This is going up by 2s, and your x values is going up by 1, 1.5, 2.5, 3.5, 4.5. So it's this number over this number. Simplify that to just 2. Okay. All right, exponents right here. 2 ways to think about each of these, right? We've got 4 7s on top, 3 on the bottom. Cancel them out. This becomes 7 to the power of 1 or 7. Okay. Another way to think about it is 7 to the 4 minus 3 equals 7 to the power of 1 or 7. These are both valid ways to show your work on this. But yeah, that's how it works. When it's division, when you're dividing the same base, different exponents, you subtract. Now, since this is multiplication, you can kind of assume that you're going to add them together, right? And the idea here is that you write out 4, 5, 6 4s for that first one, and then 3 4s. Put them together to 4 ninths, okay? Shortcut for this is 4 to the power of 6 plus 3, which is 4 ninths. Again, both equally valid ways of solving this problem. There you go. Thank you very much.